what we're going to have a look at here is the solution to what we call non-linear simultaneous equations. Okay, so these are usually characterized by x squareds, y squareds, or terms multiplied together like this. Okay, so we saw that a linear equation graph looked something like that, for example, and you would get the x and y value from there where they intersect. And a non-linear set of equations could look something like this. Okay, so we've got one function that's curvy, one that's straight, and of course this will then intersect in 2 points. So we've got an x value there, an x value there, a y value here, and a y value here. So can you see we end up with 2 x values and 2 y values. So a lot of the time with these, we end up solving quadratic equations. Okay, so this is how we end up with a couple of different answers. So if we look at then our sets of equations, so we've got equation 1 and equation 2. Now, there's multiple ways to solve these. Quite often you end up substituting, and sometimes we end up with elimination, but in this case, we're going to substitute. Okay. Now remember, the aim is to get one equation with one unknown. Okay, so it's very similar to the non-linear ones in that respect. If I look at equation 2, and again there's multiple ways you could do this, but if I look at equation 2, I can rearrange this. So from 2, I can rearrange this so that y is equals to 6 over x. Okay, y is equal to 6 over x. What you're always wanting to do with these is you want to have an equation so that you've got y in terms of x. Because once we've got that, we can substitute that then into the other equation, and we'll have an equation with either all x's or all y's. Okay, so what I'm going to do with this y equals 6 over x then is I'm going to substitute it into equation 1. Okay. So what this is saying then is wherever there's a y, I can write 6 over x. So looking at equation 1 then, we've got x plus y, but we know now that we could write that as 6 over x, is equals to 5. So we came across something like this in the linear equations video as well. Now, in order to solve something like this then, we want to get the x off the bottom of this fraction. So what we're going to do is multiply everything by x. Okay, multiply everything by x. So what we're going to end up with then, x squared. 6 over x times x is just going to give us 6. Yeah, the x is on the top and bottom, we're going to cancel. And on the right then, we've got 5x. Let's get this into quadratic form. And now we've got a quadratic to solve. This quadratic that we need to solve then is x squared minus 5x plus 6 equals 0. So of course we could do this either by factorizing or by using the formula. Hopefully you can see that this factorizes quite nicely. So again, remember what we're looking for now, two numbers that multiply to give a positive 6, subtract to give a minus 5. And also remember, and if you go back to the quadratic equations video, you'll see a little trick that if this is a positive here, both signs here and here are the same as this sign. And what we got, 2 and 3. So I go over quadratics in more detail in the quadratics video if you're not sure about that. Let's solve these then. So we've got x minus 2 is equal to 0, and x minus 3 is equal to 0. So x is 2 and x is 3. So that's our two solutions for the x's. Now, a very big mistake I see with this is that people will leave it there, okay, thinking they've solved the quadratic, therefore we finished the question. But of course, remember, we still want to solve for y. So we can sub it into either of these. It'll work either way. I'm going to put them into equation 2. So what we got then, 2y is equals to 6, divide through by 2, and we get y is equals to 3. And if we substitute 3 in for x, we get 3y is equals to 6, divide through by 3, and we get y is equals to 2. Okay, so the solution for this then is x is 2 and y is 3, or x is 3 when y is 2. Another set of simultaneous nonlinear equations to solve then. So looking at this, we've got a quadratic, and here we've got a linear function. So the idea, remember, is to get either the y's eliminated to find the x's, or vice versa. Now looking at these two equations, the handy thing here is that we've got y's on their own on one side here. So can you see that if I subtract these two equations, on the left hand side we're going to have y minus y, and the y's are going to eliminate. Okay, so again, it doesn't really matter which way around you do it, but in order to end up with a positive x squared, we're going to do equation 2 minus equation 1. Okay, because we're going to end up having to factorize a quadratic probably, or solve it by the formula. And remember, it's easier if we've got a positive in front of the x squared. If you did it the other way around, you could solve it all the same. It's just this makes it easier. Okay, so on the left hand side then we've got y minus y. I'll give us 0. We've got 2x squared. There's no x squared to take away on the top equation. We've got minus 3x minus 4x, which will give us minus 7x. And we've got 4 minus 1, which will give us 3. Okay, so I've just taken away the corresponding terms. And here we are then, we've got a quadratic to solve. Now you could do this by the formula if you wanted to, but it does factorize. Okay, so it does factorize to 2x minus 1 and x minus 3. Okay, so those are our two brackets. Split them up. So we've got 2x minus 1 is equals to 0, and x minus 3 is equals to 0. 2x is equals to 1, x is equals to a half. So that's one solution. And of course, nice and easy on the right then, we've got x is equals to 3. So there's the other solution. Now we've got to find the y's. So let's find the y's then. So remember the answers we've got then, x is a half and x is 3. I'm going to substitute these then into equation 1. Okay, so you know, just looking at these two, this looks a lot easier to substitute x into. Of course you could do both, but this is easier. So we've got then, for x is a half, we've got y is equals to 4 times a half. Okay, so same as 4 over 2 plus 1. Of course 4 over 2 is 2. So we end up with 2 plus 1, which is 3. So that's the other answer there. So when x is a half, y is 3. Let's put x equals 3 in for the other side of the equation. So we've got then y is equals to 4 times 3 plus 1. 4 times 3 is 12, plus 1 is 13. So we get y is 13 when x is 3. Okay, so these are the 4 solutions then to this set of simultaneous nonlinear equations. One last set then of these simultaneous nonlinear equations. So this doesn't look very nice, does it? We've got x squared plus y squared equals 25, and x plus y equals 7. So same thing applies then. We want to get an equation with either all x's or all y's. So from equation 2 then, I can write that y is equals to 7 minus x. Yeah, 7 minus x. If I take this to the right hand side, it becomes a negative. I could conversely do it the other way around. I could say x is equals to 7 minus y. Okay, so depending on which one you want to eliminate first, you know, that'll determine how this next step looks. So I've got y is equals to 7 minus x. What I can do with this now is I can substitute this into the other equation. So wherever there's a y, I'm going to write 7 minus x. So equation 1 then is x squared plus y squared. So that's 7 minus x squared is equals to 25. Right, so I've got an equation then with all x's, but now we need to do a little bit of simplification to get it looking more like a quadratic. So x squared plus, of course, this bracket squared is 7 minus x times 7 minus x. And now we want to multiply this set of brackets out. Okay, so what we get then is 49 minus 14x. So 49 is 7 times 7. Of course, then you've got 7 times minus x. So that's minus 7x. And then you'll have minus x times 7. So that's also minus 7x. If you group those minus 7x's together, you'll get minus 14x. So I'm just doing that to save a bit of space. And then minus x times minus x will give you a positive x squared. And that's equals to 25. Right, so let's group some of these terms together then. What we've got then is 2x squared. So we've got 2 of the x squareds here. Plus 49 minus 14x is equals to 25. And let's bring this 25 to the left-hand side then to get this into quadratic form. So we've got 2x squared. Now, if we want to write this more in quadratic form, of course, the x's then come next. So minus 14x. And then we've got 49 minus 25 that's coming over. Okay, so 49 minus 25 is going to be positive 24. Okay, so here now we've got a quadratic that we need to solve. So here's the quadratic that we need to solve then. Right, so let's make this a little bit easier for ourselves then. Of course, we can divide this equation through by 2 just to make the numbers look a bit nicer. So dividing every term by 2. So we get x squared minus 7x plus 12 is equals to 0. Okay, so just divided all of these terms by 2, and of course 0 divided by 2 is 0. So now we've got a quadratic that looks a little bit easier for us to factorize. We could have attempted to factorize that or stuck it in the formula, but this looks a lot nicer. So it does factorize then to x minus 4, x minus 3 equals 0. Therefore then we get x is equals to 4 and x is equals to 3. So there's 2 solutions. Now we want to substitute these, of course, into either of our 2 initial equations in order to get y. So I'm going to substitute it into equation 2. So if you remember, equation 2 is x plus y equals 7. So we're going to sub it into that one. So what have we got then? 4 plus y is equals to 7. Y then is equals to 7 minus 4. So we get y is equals to 3. And on the other side then, I'm going to put 3 in. So 3 plus y is equals to 7. Take this 3 to the right-hand side, and we end up with y is equals to 4. Okay, so these are the 4 solutions to the equation. X is 4 when y is 3, and x is 3 when y is 4.